We want to take care of those really fast so we have plenty of time for our lesson today. So the first one is a radical simplification once again. So we have a 2 out in front of the radical, but we're going to simplify the radical and find out what else is going to come out. So the 27, that breaks down into 3 times 9. And 9, that 9 is going to break down into 3 times 3. So let's go back and kind of write that down here. So as long as we know where we're going, we're going to have a 3, and 9 breaks down into 3 times 3. And then remember with the x's, we have 3 of those, so x times x times x. And with the y, we have 6 of them. So 1, 2, 3, 4, 5, 6. All right, let's circle the pairs of factors we have. We have a pair of 3's, we have a pair of x's, and we have 3 pairs of y's, as you can see. So if we take one of each pair out in the front of the radical, we'll have the 2. So let's bring that 2 down. That 2 comes down. And then we're going to have one of these 3's, one of these x's, and then one of each of these y's. So y, y, and y. And then we have our radical, and what's going to be left inside is just this 3 and this x. So when we get all of these multiplied out, 2 times 3 is 6. And x times x is, there's just one x, sorry. So x. And then you have y times y times y, which is y to the third. And then the radical with whatever was left inside, which in this case was 3x. So that's what that radical would look like after you simplified it. That's kind of a challenging one. So good luck on something like that. I think you can do it, though. Okay, find the value of x. So we know that this is a right angle because of the little square box here in the corner. So x is just going to be 90 minus, oops, I want a minus, not a fraction bar there, x, 90 minus 41. So we go like that. 10 minus 1 is 9, and 8 minus 4 is 4, so we got 49 degrees. And that's what our angle x is, 49. Okay, find the value of y or the given value of x, for the given value of x. So in this case, we're just going to substitute 1 in right here and then calculate what it all equals. So this is going to be just 13 times 1 minus 3. And 1 minus 3 is negative 2. So negative 2 times 13 is going to equal negative 26. So there's the value of x if, or the value of y if x happens to be 1. So there we go. All right, moving right along. Today we're going to be talking about similar versus congruent. So figures that have the same shape and are the same size are considered to be congruent. Their corresponding sides and corresponding angles are all equal. All right, so that's congruent. They have the same size sides, same shape, and the same angles. So here's a symbol that means congruent. So this triangle is congruent with this triangle. Okay, so you got an equal sign with a little squiggly line above it. However, if you look at these next 2 triangles, they are not congruent because you have the angles are marked differently, which means they're a different value than these 2 angles. So those are not congruent. Okay, so here's a sample problem. Which pairs of figures below are congruent? So you look at these, and these certainly are. This looks like a reflection, but they are the same size. Sometimes you have to be careful and make sure that this length here is 4, this length is 4, and so on. The next one, these certainly don't look like the same shape, so they're not congruent. These are a different size, so they are not congruent. These, you got a length of 4 across the bottom and left sides. 1, 2, 3, 4. 1, 2, 3, 4. So these look like they are congruent as well. Good. Okay, identifying the naming congruent parts of a congruent triangle. So this can be kind of fun. So if these two triangles are congruent, we want to name the corresponding parts. So this first one is comparing the angles. Angle A corresponds to, now if you look, angle A is between the two sides where you have 3 marks and 1 mark. So let's see, 3 marks, 1 mark. So angle A is going to correspond to angle X. So angle, oh no, that's not true. Okay, angle A is in between, yeah, here's angle A right here. And there's 3 marks and 1 mark. So 3 marks and 1 mark, so that's going to make this angle X. Okay, angle B is in between the two lines that have 3 marks and 2 marks. So 3 marks, 2 marks, so that's going to make that angle Z. And then the only angle that's left after we've used up X and Z is Y. Now you could also say, oh look, this angle has 3 marks in it. Angle Y also has 3 marks in it, so that's why angle Y corresponds there. Okay, next, sides. So the side A and B, this side A and B is the side where you have the 3 lines, meaning that's the same length as this side. So in that case, you're going to have X and Z inside your box. So the line A and B, of course, is congruent to the line X and Z. The line A and C, which goes through the length of the one with this 1 mark, so that's going to be Y and X. Okay, actually you probably want to do X and Y because it should be alphabetical order, and W, X, Y, Z. So we'll go with X, Y. And then the length BC, so it'll go from BC down to this length right here has got 2 lines measuring its length. So that would be the same as Y and Z. And since we know that all 3 angles and all the sides are congruent, that means the triangle BAC is congruent to the triangle Z and X and Y. All right, so there's a congruency statement. So be sure to pay close attention to the number of marks that are on the line or on the corner, and they help you to correspond with those down here and what order to put them in. Okay, triangles with exactly the same shape but are different sizes, these are called similar triangles. And so their corresponding sides, if they are similar, have the same ratio, which means, for example, this side over here is twice as big as this side. Comparing the other 2 sides, this side right here is twice as big as this side. And the third side right here is twice as big as this side. So that means that they have the same ratio, they are similar. Also, if they are similar triangles, their corresponding angles are congruent. So this is kind of interesting. The sides are proportional, they have the same ratio, but the angles are exactly the same, as you can see here. We've got a 95-degree angle, a 65-degree angle, and some 20-degree angles. Okay, keep on moving. Tell whether the triangles are similar. Explain. So if you look, you notice you got a 50-degree angle here, 50-degree angle here. What you don't know is what this angle is here. So if you add these 2 together and you end up with 105 degrees, and if you subtract that from 175, or excuse me, 180, 180 minus 105 would give you a 75-degree angle. So y would equal 75 degrees, which is the same as as this 75 over here. So then we know that x is 55 as well. So they are similar. These two are similar. How about these next two? Well, you've got your right angle, and you got a 38-degree angle. Let's see, what's 180 minus 38? Well, that would be 142. All right, and then we notice that we've got a 142. So that means now we're going to subtract off the 90 that we already know we have. And when we subtract 142 minus 90, we get 52. So this is going to be 52 degrees. Okay, so if we look at this triangle, that's a 42-degree angle, and 90. These are not similar. They don't have the same angles all the way around, so not similar. Similar. Okay, all right, so let's keep on moving. Okay, finding angle measures of triangles given two angles of a similar triangle. So you're kind of doing the same kind of deal here. So you know that measure of angle I is 20. You know that the measure of angle G is 110. So that's going to tell you that the angle H, just in case we need it, is 110 plus 20, which is 130, minus from 180, which would give you 130 from 180 would give you 50 degrees for this angle down here. Okay, now let's find the measure of angle X. So the measure of angle X is going to be 20. The measure of angle Y has got to be this obtuse one, so it's got to be 110 degrees, which would make a measure of angle Z the same as a measure of angle S, or H, I mean. That means it's 50 degrees. Okay, very good. Use similar triangles to find a missing measure. Use the ratio of their sides. Okay, so we know that the sides are proportional, and we want to find these two missing sides. So if we look at the two sides, corresponding sides that we know, we notice that if I multiply the smaller side by 3, I get the larger side. So 3 times 3 equals 9. So in order for this to be similar, we have to continue that same tripling of the side length. So we're going to multiply this by 3 and this by 3, and that's going to give us a side length of t of 15 and a side length of s of 12. So there are our 3 side lengths in order to make those the same ratios. Okay, finding the missing side measurements. Okay, here we only have one missing side measurement, and that is P. So all we have to do is find P, and let's ask ourselves, what side of this triangle corresponds with P? So if you look at, we're going to have to kind of check this out. This is going to be, if you notice that 7 is half the size of 14, and 14 is half the size of 28. So that means that this P has to be twice the size of 12. So since all of these are half as big as these, so if I times that by 2, I get P equals 24. All right, so good. Okay, finding a missing side length given two similar triangles, a triangle ABC and a triangle PQR are similar, find the missing side length. So if they're similar, they are going to be proportional. So I notice that if I look at these comparisons to go from 7 to 63 here on the bottom, that means I'm timesing by 9. If I times this by 9, I also get the 45. So that means if I times 8 by 9, I will get my missing side over there with the question mark on it. 8 times 9 is 72. So that's going to be a 72 length on that triangle to make these similar. Okay. All right, so here's a situation. You plan to cross the river and want to know how far it is to the other side. You make a measurement on your side of the river and make the known drawing, make the drawing shown. Okay, so you got a common side here on the hypotenuses, and you have two 90-degree angles. And because you have a set of vertical angles right here, you know those two angles are the same, which means that this last angle up here and this last angle down here have to be the same as well. So why are these similar? You have the same angles. So same angles, but we happen to notice that the side lengths are different in length. So that's kind of what similar means. Different sides, but same angles. Different sizes. Okay, so the question that remains then, what is the distance x across the river? So I'm going to write down what I'm looking for. I'm looking for x, and it corresponds to the side on the other triangle of 60. So this length and this length are in the corresponding positions. And we know this has to equal the other two side lengths in a proportion. So the other two side lengths that I have are 50 and 40. And since I'm going to use, I've got 60 on the bottom down here, I'm using the biggest number on the bottom. So I'm going to use the 50 on the bottom of this fraction and the smaller number on top, which is 40. So all I have to do is cross multiply and solve this. So I'm going to grab my calculator. I'm going to do 60 times 40, which is 2,400. Okay, that's pretty big. And then we're going to divide that by 50, and we are going to get 48. So x is going to equal 48. And that would be 48 feet. So that would be the amount that made sure that these are similar triangles. Okay, similar right triangles, find the length of x. So to find x, I write down x. Then I make a ratio between x and the corresponding side on the other triangle, the smaller one or the bigger one, whatever the case may be. Then I make another ratio of the smaller to the, or bigger to the smaller side on with the other two measurements. So 7 over 3.5. All right, and when I do that, I notice that 7 divided by 3.5 is just 2. So x over 2.5 equals 2. And when I cross multiply 2.5 times 2, I get a grand total of 5. So my missing length x is 5. Okay, so suppose a flagpole casts a shadow that is 21 feet long. A student that is 5 feet tall is standing next to the flagpole and casts a shadow that is 6 feet long. What is the length of the flagpole? So remember, we're looking for the flagpole here. So I'm going to write down x over 5, the corresponding side, which is the height of the person. And then the same ratio of numbers, the big one over the small one, in that fashion. So now all I have to do is a little bit of a proportion. So I cross multiply and then divide by 6. And when I do that, I get my calculator going. I have 5 times 21 equals, and then I divide that by 6, and that's going to equal 17.5. So x equals 17.5 feet tall. Okay. All right, so that's the kind of problems we're looking for. It's going to be on ALEKS. It's called Similar Figures. Good luck.